Hi, friends. I'm John Kempf, hosting this podcast. I'm passionate about developing regenerative agriculture systems that improve soil health, produce crops that are completely resistant to diseases and insects, and produce fruit of such an exceptional quality that we can have a legitimate conversation about growing food as medicine. I've discovered that there are many people with incredible knowledge and information about soil and plant systems and how to develop regenerative agriculture systems. However, much of this knowledge and this information is scattered. It's found all over the place. Some of it has been published in peer-reviewed publications, but there are many incredible stories and a lot of knowledge that has not been published and that hasn't been shared with many people. I started Advancing Eco-Agriculture in 2006 to bring this knowledge together in a more coherent fashion and incorporate it into products and growing systems that growers can easily put into practice. It's my personal mission to have these regenerative agricultural systems become adopted globally and become the mainstream, the status quo, against which all other growing systems are compared. To help achieve this goal, I want to share the knowledge that we have learned in the last decade and make it available to everyone. While we have developed products at AEA that embody the principles of regenerative agriculture systems and make them easier for growers to apply, this knowledge and these principles can be applied anywhere, and when they are applied properly, they will always increase farm profitability and resilience to climate stress. If you have any questions, suggestions, comments, or ideas, topics that you would like for me to discuss, please connect on LinkedIn or on Twitter, where my username is @VisionBuilder7, or you can also email me at john@johnkempf.com. I would very much like to hear from you and to hear your feedback. Be sure to subscribe to this podcast, and thank you very much for listening. Enjoy the show.
In this podcast episode, I had a lot of fun in an interview and discussion with Klaus Martens, who is an organic broadacre crop farmer from upstate New York, the Penn Yan region with Lakeview Organic Grains. Klaus and I have a very fun discussion around weed management, using cultural management practices, using appropriate tillage, using crop rotations to manage perennial weeds and annual weeds, and to really shift the weed populations of a farm over time. At the beginning of the podcast, the audio quality is a bit of a challenge, but stick with us. As we get a little bit further into it, the audio quality gets to be a lot better. And we have a fascinating topic. Klaus has some very key insights into how to manage a number of different key weed species that I know many of you will find very insightful and will enjoy a great deal. So thank you for staying with us, and I hope you enjoy.
Welcome to the Regenerative Agriculture Podcast. On this podcast, we explore the science and the practical application of regenerative agriculture ecosystem, how to regenerate soil health, crop health, quality, and very importantly, how to increase farm profitability. The goal that I have is to really give you clear and easy to understand and actionable information that you can implement on your operation. In this episode, I'm very excited to welcome Klaus Martens from Lakeview Organic Grain in upstate New York. Klaus has been very successful at developing organic farming systems to develop high quality, develop exceptional yields, high quality small grains crops and various grain crops, and has also developed very effective weed control systems. So Klaus, we're very honored to have you. Thank you for joining us.
All right, thanks for asking. This has been quite a journey for us since the last 25 years to go from being fully conventional farmers who used all the chemicals to completely convinced organic farmers, which I think is probably, we're not unique in that. I think you have a similar experience, don't you?
Well, certainly the farm that I grew up on, we were very mainstream, using very intense pesticide application. And today the farm is not organically certified, but there is no insecticide or fungicide or herbicide use at all. So no synthetic pesticides of any kind.
Yeah, it's a real journey in learning. And you wouldn't have had the handicap that I did, if we can call it that, of having gone through the land-grant university system, learning how to farm correctly, and then having to unlearn a lot of things before things started to work.
Yeah, I've several of the mentors that I've worked with have told me that I would not have been able to learn what I've learned so far, or in the speed that I learned it with a university education, which I don't have the context to be able to comment on that, but I found that to be an intriguing observation for sure.
I found it to be both handicap and help. I found that there are people in the university who are really good, honest scientists who can have offered me a huge amount of help in figuring things out. The handicap more in what we were being taught and how we were being taught to think and look at the farm. There's a real reductionist way of looking at nature that I think prevents us from seeing the whole truth sometimes. And I had to step beyond that. In fact, one of the things that bothered me when we farmed conventionally was that if you took the model that I had learned and the assumptions that I was farming under, the observations contradicted them. And it was enough to drive me crazy sometimes because I either had to discount my observations or question my assumptions. And for a lot of people, it's actually not very comfortable to question your assumptions.
I think it was a quote by William Albrecht, University of Missouri, back in the 50s, who said that the quote was, "You read books and study nature, and when the two of them don't agree, you throw away the books." I've always chuckled at that.
And even there, I think there was some truth in the books, but not complete understanding. And we have to figure out what part of it is useful and which part is not, which asks more of us than just reading it, writing it back.
Yeah. So, Klaus, you've been on a very interesting pathway. You've done some fascinating work on your farm. What have been some of the memorable moments that led you to where you are today?
Well, there's one that I talk about in a lot of our talks. It happened at the Cornell University Library. When we first converted to organic, like a lot of people, we were looking for what organically approved inputs we could substitute for our fertilizers and which organically approved techniques or machines or whatever we could substitute for our herbicides. And in searching the library stacks, it became obvious that we were looking for weed control and fertility books from before 1945, and it seemed like there weren't any until my wife suggested that maybe we should look in the archives and stacks, the older stuff. And it was almost funny that you couldn't find anything that was printed before then until we went into the stuff that had been put away for storage. But there I ran into what had been my ag teacher's old text written by Kraft and Rayner. And in the bibliography of that, I found a paper written by a German professor in the 30s who was the pioneer in using chemicals to control weeds. And the quote, I wasn't quoting it exactly right. I just reread it here a couple days ago. And what he wrote was, cultural practices form the basis of all weed control, while the various chemical means should be regarded as auxiliary only. Kind of an interesting comment coming from the pioneer of spraying weeds.
We've certainly shifted from that paradigm substantially.
Yes, we have. And here was the visionary who started a practice actually telling his students, do not rely on this. It tells me he saw a lot of things that maybe people since then haven't seen. And that got me to read because it turned my worldview upside down. This is practice that I had learned is always reactive, that you identify the weeds and then you figure out which poison will kill them and hopefully not hurt the crop as much as it does the weeds. And he was telling us to look at cultural practice. So that made me ask, well, what are cultural practices? And cultural practices are everything you do in the tending of that field. What we did that set up the situation that the crop was growing in. And the idea that what we had done before had an impact on what the field was like was kind of radical and new to me, although it did fit what I had observed. I saw patterns that they weren't making sense, and I kept having to ignore them. So rotation is the obvious one, but in this paper, he went through all kinds of examples of different practices that could impact which species were there. And also an idea, this wasn't in the paper, but it was inspired by the paper, something that I had seen and observed, and that is what happens when you abandon a field. And I've used this example enough so I think everyone gets tired of it, but it seems to always work because it draws out what people already know. First year after you abandon a field that's been in row crops, let's say it's in a cornfield, think about what weeds will grow. And, obviously there'd be lamb's quarter, pigweed, foxtail, velvet leaf, the whole range. They're mostly seeds, weeds that make huge numbers of seeds. And you end up with a seed rain that could be millions of seeds per square foot. Could be many millions of seeds per square foot that are falling on the field. But what grows the second year? And from our reductionist way of thinking, we would assume that because we've just made that many seeds, we should have a lot bigger problem of the same thing. But the second year, none of those plants are growing. We have other weeds growing there. And if you take that fast forward several more years, you start seeing goldenrod, start getting woody plants, brambles, sumac, all the thorny stuff, multiflora rose. And if you take it forward a few more years, you're going back to forest. This is something Dr. Albrecht wrote about. And if 500 years, at least where we are, it would be back to old growth hardwood forest, mostly oak. And Dr. Albrecht called that the climax crop. That's what nature, that's kind of a steady state that nature would put the land in. And if you think about it, this is how the land was made to work. It creates this succession where all of the succession species and communities, each one changed the soil. The reason all of those weeds that set seed, those seeds didn't grow the second year was that the plants that made them had changed the soil and that the right conditions weren't there for those plants to grow the next year. So other plants grew. And that group, again, changed the soil so that another group grew. Now, thinking back to what Dr. Albrecht wrote, he talked about these successions as actually being more productive, more diverse, and more vibrant than the climax crops, so that the tall grass prairie and the oak would have been very stable, very resistant to invasions and diseases, of insects. But it really didn't have that much diversity in it, and it was not quite as productive as the succession communities. But it was very, very resistant to any kind of problem. These plants didn't get sick. They could tolerate floods, storms, whatever, and just remain in very healthy, good condition. And the reason I'm making all this description is that this is all part of what Albrecht used to tell his students. See what you're looking at. See how nature does its crop rotation. So, go ahead.
Why did you look for books that were written prior to 1945?
Well, I was looking for that because my father used to tell me, he used to laugh at me when I said, well, we need all these chemicals. And he said, well, how do you think people fed themselves for most of history if those are needed? These things are all recent. And I just reasoned that if I look back at these agriculture books from before 1945, I might be able to learn how people farmed back then and how they actually made things work. And that was my reductionist thinking to some extent, but I was reaching back to older knowledge. And we've lost a couple generations of people who passed down from, one generation to the next, all this stuff, because, it all suddenly became irrelevant when the chemicals came along. And I just didn't know what else to do. I was in a situation, and I'll digress here. The reason we were wanting to make a better living, but partway through our transition, I went to pull up the sprayer and found that my right arm was paralyzed. It wouldn't move. And I spent the summer paralyzed. I went to a naturopath and a chiropractor who finally restored the use of my arm. And we had a decision to make because at this point, hiring somebody to do a job that I figured would probably kill me or harm me in some way was not something that as a Christian I could do. I mean, there's something morally sick about hiring a job that you're convinced is going to harm you. Hiring someone and telling them to do a job you are convinced it's going to be harmful. So that placed me in a spot of, if we want to do this for a living, we have to figure out how to do it without using these things. So that puts a little more perspective on our visit to the library, where we were desperately trying to figure out how do we remain farmers, but do it in a different way.
With the pieces that you've learned from the research that you've done and the description that you've just shared about natural crop succession and, or I guess I should say perhaps plant succession in developing soils, how have you found that useful for managing crops and for managing weeds on your operation?
Okay, I'll have to digress a little here. I mentioned that there was a conflict between my observations and our assumptions. All of these observations, when I think about them correctly, were pointing to a system that was very carefully engineered, with an intelligent design behind it that worked according to a logic and an order that was not random. I had to shift from thinking that these are all random occurrences that we're seeing to that these are the result of an order. And looking at the world that way, we suddenly realized that this is all cause and effect, that what we do today, we will see the results of later. So this really helped us in starting to understand what we had seen. And Dr. Albrecht used to love to say to a student, see what you're looking at, but not just see, we have to understand it right. And in order to understand it right, another mentor I had just framed it this way. He said, if you want to get the right answers, you have to figure out what are the right questions. So instead of seeing my field of velvet leaf and just framing the question of how do I kill it, which is what I've been learned, that when I see these random events, that all it is a challenge, that the only question I need to answer is how do I kill this, because I don't want it here. I needed to ask, why is it here? What's more, what is it doing? What did the creator put this here to do? Why did he put it here? And what was its function? A lot of questions. I could keep on coming up with these questions that I'd never thought about, but they're important. So when I saw started looking at a pest, it forced me to start asking why it's here and what exactly is it doing in the soil. Take this back to the succession that we observed. Obviously, these plants are changing the soil, and left to their own device, they kind of work themselves out of the job so something else grows. Where this took me in the logic was that I had to look at everything that I could observe. I had to try to see everything there was to see, but look at it through new eyes, look at it through something that is working exactly as it was intended to. And the problem was me. If I didn't like something, I had to own it and say, this is the result of what I've done up until now. Now, how do I change that? More importantly yet, how do I learn from it? So I started to study, what do these different weeds and pests do in the soil? And from that, maybe have a hint. And that kind of grew into a system of, how do you read what the soil is telling you? And how do you understand the language that your fields are using to try to teach us? And, from each of these things, there were observations made that I learned from. I'm going to shift gears for you and take this back to the university. And I'm going to jump a little bit. I'm going to tell two stories. One was about a weed that I thought was going to make it impossible for us to farm organically. At one point, I was really frustrated. It was velvet leaf. And it seemed like the velvet leaf grew taller than the corn. No matter how carefully I cultivated, there was always a lot of it survived. I had one spot in particular where I ended up mowing it, about 1 acre of it first year, because the corn, there was going to be no crop. There was none there but velvet leaf. And let's fast forward this. I don't have time to go into all the details, but I wasn't even noticing that after about 4 years, it wasn't quite as bad. And the spot where the crop didn't amount to much, that was smaller. And went forward another 3 or 4 years, and lo and behold, my velvet leaf was getting into midsummer, and then it was starting to turn yellow. The lower leaves were turning brown, and the lowest leaves had fallen off. And then as I watched it, there were more and more leaves falling off. And before the end of the summer, it was dead. Not only that, but instead of being taller than the corn, it was only about 3 to 4 feet tall. So I called a friend at Cornell who was a weed ecologist, Tony, and I was still thinking completely wrong. I was saying, if I found a disease here that's going to make me a millionaire, and told Tony my brilliant idea and that we could catch these spores and make a product out of them. And Tony came out and looked the situation over. He said, I'm familiar with this disease. Before you can go ahead with your plan and before it can be successful, you need to explain this to me. Why is it when that disease is in your neighbor's field on his velvet leaf, it doesn't hurt the velvet leaf? And sure enough, this disease existed right across the road, and it wasn't hurting the velvet leaf. Now, it did bump me on the head with confusion, but I should have been able to figure this out quicker than I did. I have to admit, I was quite dense. I needed quite a few lessons and noticed quite a few things before I started putting 2 and 2 together the way I'm explaining it. So the next thing we noticed, there was a second disease in that velvet leaf. One of the students at Cornell identified a virus. And in the meantime, because I was paying so much attention to this, thinking that this was going to be my new product, I noticed that those leaves were covered with whiteflies. The first time I saw it, I called an agronomist and said, look at all these whiteflies. My weeds are just being eaten alive. And the agronomist said, wait a minute, you better watch out. You're not going to have a crop left with all these insects out here. But then we looked at the corn. There weren't any bugs on the corn. Corn was perfectly healthy, growing well. It was only the weeds that had bugs on them. So to kind of jump ahead a little more, the insects were actually carrying the virus, and the fungus was blowing on and killing them. But it wasn't this complex that was actually killing the plant. Those were just opportunists. We had changed our system so that was a very unhealthy soil environment for the weed. And because the weeds were unhealthy, all these pests were moving in and attacking the weeds. So it wasn't really the pests that killed the weeds. They were just there because the weeds were sick and weren't fit to live. So I think I'll pause there. I don't know if you could think of any follow-up questions or things I missed on that piece.
We've actually observed a very, very similar situation on farms that we've worked on after developing the soil ecosystem for a couple of years, where this one farm that comes to mind had major challenges with Canadian thistles. And after a couple of years of being in a small grain rotation, forage rotation, planted back into a corn crop, and I actually have a number of photos of this, we went back into an organic corn crop, no herbicides applied, and it was cultivated. The cultivator got most of the Canadian thistle, but there were still the Canadian thistles that were left right in the row. And by the time the corn was tasseling, all the Canadian thistles were dead. They were brown. And we sent those into a laboratory as well to try to identify if there was a pathogen or disease that had infected them. And we weren't able to find anything on the dead plants. It was quite an interesting experience.
Okay, that was actually a good example for you to bring up. How did you decide, or how did you interpret that?
How did we what? How did we discover that?
Or how did you interpret what you were seeing at that point? Did you figure it out right away, what was going on, or?
Well, our interpretation was that we had changed the biological profile of the soil biology to such a degree that the rhizomes were no longer able to survive, and that the plant ended up dying. Because actually, what the really interesting part was that it wasn't just the upper parts of the plant that were dead, but in fact, the entire root system. And you know how ubiquitous a Canadian thistle root system can be. They were dead.
Yes.
They were completely decomposed.
Yeah. So I could bring you a piece of this that might be interesting to you then. I have a friend whose great uncle researched Canadian thistle in Germany at the university, and he discovered there's an organism that lives on the root system, on the deeper roots of the Canadian thistle, and that the thistle needs this organism to survive. It's a symbiont, and this particular organism can only live in anaerobic soil. The oxygen is deadly to it, and that fits what you saw probably.
Yeah, fascinating.
And, so the subsoil that was compacted, and Canada thistle tends to start in the wet spots and the low spots, would be anaerobic, and if it had everything it needed, it would grow and it would spread. But once there's also a poem. I don't know if you remember. Farmers used to say, "Cut them in May, they'll be back in a day. Cut them in June, they'll be back soon. Cut them in July and tell them goodbye, Canada thistle."
I've never heard that one before, but yeah, it sounds interesting.
Yeah, and that fits what an old farmer mentor of mine once. I had a patch, and he said, "I want you to I'm going to do something here, and I want you to pay attention because you're going to learn something." So just about the time those thistles were in full bloom, he took my mower and headed out there and mowed them down. That was in July. They come in full bloom in July. And he said, "They're gone now, and they won't come back." And he was right. Well, that fits because those big roots in July, when the plant's blooming, have shrunk. That's when the most energy is in the top. So because they've shrunk, they've created air passages that brought oxygen down. And when we cut the tops, they shrunk even more to try to rebuild their tops. And that did away with the anaerobic conditions in the subsoil.
Fascinating.
So you've seen that. Yeah, you've seen the results of it.
Yeah, the question that comes to mind for me on the discussion that you have, what you've shared with the velvet leaf, the story that you shared regarding the velvet leaf, is what do you attribute that shift and that success to? In other words, if you were to give advice to other growers around the country, how can you replicate that success? What is the system or the process to follow to achieve those kinds of results? And perhaps not just with velvet leaf, but possibly also with other weed species.
Right. So we're asking that question, and I told this story twice in a row now at a graduate class at Cornell, and the students in this class are hoping they can help answer this question exactly like you're asking it. And what they've done is they've come out to our farm and they've collected soil that they planted in the greenhouse now and planted velvet leaf in, and they collected soil from a conventional farm that was suffering from really bad velvet leaf. They're putting them in the greenhouse under the same conditions, and they're going to do microbiological assessments and every measurement that they can think of, hoping that they can reproduce these results in the greenhouse side by side and start explaining to us on a very basic scientific level what's going on. The bigger picture is what I'm attributing this to is I think the soil has a different biology in it. I know that the velvet leaf, at the same time my pigweed and my lamb's quarter has really been reduced. These are all non-mycorrhizal wheat. And here, this is my guess talking. I'm hoping the university gives us the true answer and can prove it. But my guess is that the mycorrhizae on our crop roots are actually attacking the non-mycorrhizal weeds or somehow going after them to help the crop compete with them. And the reason I'm guessing that is that a researcher from University of Wisconsin, once after I talked about similar observations, said that he had, in some of his plots, had observed a 90+% reduction in the growth of non-mycorrhizal weeds that he was guessing was due to the mycorrhizae on the crop plant. But he said he couldn't reproduce it because the soil, he was doing it in different soils, and it seemed only in certain soils where the mycorrhizae were able to attack and throttle the growth of the non-mycorrhizal plants. Well, my guess there is probably it was the healthier soils that were friendly to mycorrhizae were giving him this extreme suppression of weeds, and the unhealthier soils weren't. But when you do statistics on single factor analysis, the result is you didn't see anything, which obviously we know he did see some. So does that fit what you've seen?
we've observed, it's been hard to identify for us, working in many different farms, many different types of environments and ecological regions. It's been hard to identify consistent themes. So the way that I've usually presented this discussion is to say that as you shift soil biology, weed pressure shifts and weed populations shift. And I would say 90+% of the farms that we work on, within the first 2 to 3 years, their weed populations shift. What was once a dominant and major weed species is now subordinate, and it has been displaced by another weed species entirely.
Okay, so you're changing the microbiology of the soil. I'm a little more. I'm trying to figure out exactly how we're changing it, and get the details. We don't really have to know the details to have that work in our favor. Just like I'm sure you and many of your clients have figured out that they can benefit from it, whether they know how it works or not.
Yeah, and I'd like to go back and ask you that question. You perhaps haven't figured out exactly the causal mechanisms of the effect that you had on the velvet leaf, but what were the practices that you were doing that you believe led to this result and to this outcome?
Well, we were going to a much more diverse rotation. We had started putting cover crops on everything so that we tried not to have the soil uncovered over winter. We were plowing a lot more green matter in, but as much as anything, this diverse rotation changed our soil. And something that I've mentioned in the past, and that was one of my early epiphanies, was that I noticed after we'd started converting to organic, I was plowing a field and I smelled something that I hadn't smelled since I was a little boy. And that was, I used to love to ride with my father when he plowed. The soil had this powerful smell that I just absolutely loved. And I've learned since that scientists have discovered that smelling this material actually makes you feel happy. It has a psychological effect on people.
Fascinating.
It's called geosin. You know the smell. I don't have to describe it, do I?
Yeah, I know the smell. I know exactly what you're talking about.
Yeah, and that smell came back, and that was actually one of my first big observations. But I'm pretty sure that smell is a vital sign that you can read on soil to tell you that it's heading toward healthy, that it's healthier than it was. If you don't have that smell, it should be a warning sign that something is not working right.
I completely agree with you. And that's actually an indicator that we use when we are scouting in a farmer's field, as we want to know what the soil smells like. And it's incredible how fast it can change. I think perhaps the fastest that I've observed or that I've personally experienced was working with a strawberry crop in California. So it was relatively sandy soil and the biology could change fairly quickly. And that soil went from having no smell, like it was the equivalent of a sandbox, to having that rich, earthy smell in 2 weeks. It was almost unbelievable.
So the biology is so powerful and can change so fast. And I think that's really one thing we're missing is we're looking at the big plant. First of all, we're looking above ground because that's what we see. We should be looking below ground, but also we're looking at the big things and we should be looking at the microscopic. It's kind of harder to see them. And out of sight, out of mind, I'm afraid is something that hampers us. But this biology of the soil, I'm going to recommend a Baker's book to you and everyone else. Maybe you've read it. It's called Healthy Soils, Sick Soils. It's a translation from German, a work done by an Austrian researcher back in the 40s and 50s. And I think it was published in the 60s by his widow. And he actually took soil and put it on a dissecting microscope and was trying very painstakingly to see what he could see. And he used stains and what at that time was the most advanced techniques. And he found an entire ecosystem in the soil, in these pores that were in a healthy soil. And what he discovered was the organisms in it were all aquatic. They're all water-living things. And there was this whole world of thousands, possibly millions of different species when you count the bacteria, but also larger things that were all living in the water films in the soil. What's more, they were being fed by the exudates from the crop roots. That's one of the mechanisms that I think the crop is orchestrating biology with by the type of food that it's pumping out of the roots. And think about if people ever think that tithing is difficult and you have to give some of our bounty back, think about plants who are giving half as opposed to 10%.
Yeah.
And think about the number of species that these plants are cultivating around their roots and what they must be doing. And of course, we're only seeing the results.
Absolutely. In some cases, I think Horst Marshner, actually in Petra Marshner, the third edition of Soil Nutrition and Higher Plants, refers to some plants in some conditions can actually contribute as much as 70% of their total photosynthate production back to the rhizosphere as root exudates. That's an incredible number when you stop to think about it.
Yeah, and it's not foolishness on the part of the plants. This gives back just enormous changes in how the soil is, because these organisms are what builds the soil. Another thing that was in this book by Sakara was that they took soil that had good aggregate stability and put it in the lab at 70 degrees, just a sample. Within 2 months, the aggregate stability had broken down. And that was the conclusion was that these organisms were
breaking down at 70 degrees Fahrenheit is incredible when you consider that many soils are during the growing season and the cropping season, they're exposed to the sunlight, and in many cases the top couple inches substantially exceed 70 degrees, sometimes as much as 120 degrees or greater.
Exactly. And what Sakara was saying was these organisms were physically what was building the soil, the structure the way it was, but they were needing the sustenance from the plants. And at 70 degrees, starvation set in, and these plants couldn't hold the soil together, or these microbes couldn't hold the soil together anymore because they'd starved to death. Did the same experiment with a pesticide dumped into the soil, and the soil fell apart within days.
Wow. What was the author's name of this book?
This was Margaret Sakara. It's an Acres USA book.
Okay. Healthy soils and sick soils.
Yes. And it talks about tillage, and it talks about the building and maintenance of crumb structure, and it gives some rules for tillage. It says you should never disturb a soil deeper than what you can than it's already developed a healthy crumb structure to, because below that layer it can't rebuild.
Intriguing. So, Klaus, going back to our conversation about weeds and cultural management of an ecosystem and how that might lead to shifting weed populations, there's also an interaction, if you will, between weeds and the crop that we are trying to produce. I know that in a previous conversation, you mentioned an experience that you had with producing dry beans and mustard being present in the fields. Can you tell us a little bit about that?
That was my second example. I'm glad you steered me back around to the second case that I wanted to describe. When we first converted to organic, of course, one of the things we noticed was that we suddenly had customers wanting to buy almost anything we could grow, which was quite a switch from taking corn to the elevator and seeing how bad the price was going to be and if we could still make any money at it. When we went to organic, it was more or less, well, what would you charge me to grow this? Or what would I have to pay you if I could buy some beans? So dry beans was almost like printing our own money at first. They were so profitable and the yields were terrific. And, I was very happy with them. But after about the second time that I grew them, and even five or 6 years in between, when I planted them again, I decided I must have gotten bad seed, or I got a new variety of seed, and it was just not as good because they weren't growing as well. And by the third time I grew these beans, the roots rotted off and the yield had collapsed, and the crop really was awful. And I went to Cornell again. An old friend there, Georgia Bowie, was near retirement, and he had studied nematodes and roots and fungi. And he said, I've been in this business all my life, and I've always wanted, when farmers came to me with a problem, I always wanted to explain to them what was causing the problem. And they always said, no, don't bother with that. Just tell me what to put on it to kill these things. And he said, finally, now that I'm ready to retire, someone's actually asking me what's going on. And he was very happy to help us. So he explained to us that there were root fungi, pathogens, that were not just carried by this crop, but even though it might have been 5 or 6 years since we'd grown dry beans, he said, what else did you plant in between? And I told him that we were growing red clover and that we would seed our small grains down to red clover, and we were growing soybeans, and we had this really nice, healthy, diverse rotation. And he said virtually every crop you're growing either leaves the problem, the number of root disease organisms the same, or makes them worse. So that when you've rotated, by the time you're back into dry beans, you've multiplied the amount of disease pressure that's in there, because not one of your crops that you're growing in that rotation actually reduces these pathogens in the soil. They all just promote them. And he developed an interesting experiment. In his experiment, he asked the question of how will the previous crop affect the root rot complex in dry beans. And he picked a very susceptible variety of dry beans, one that had no root rot resistance. And he took a field that was fouled with a disease, and he cut it into squares, and he planted, I think, 20 different crops, had them in a random block, so they turned up at random in different spots in the field. And he planted these susceptible dry beans, and he noticed that some of the plots, the dry beans looked great. They were growing and thriving. There were other plots where the dry beans actually died because the roots had totally rotted off. And then he started asking about, well, which crops, what is the right previous crop for the dry beans? And he noticed that there were some crops made the problem a lot worse. Some made it a little worse. Some were neutral. Some helped it a little. Some helped it a lot. And a couple of them devastated the disease complex and ended up with very healthy dry beans. And the best one he could recommend from that was yellow mustard. And that's kind of a talk in itself, all the mechanisms of yellow mustard breakdown that kills the dry bean disease. But we also realized later that it wasn't just the disease that was in the ground, there were nematodes. And the nematodes were abrading the roots and chewing them up, which allowed openings for the disease to move in, which is why the dry beans had such terrible roots. And as a side note, I looked when I was studying this problem, there were pictures of dry beans back when the Native Americans grew them in their system. And some of those roots were 4 feet deep. And I couldn't imagine dry beans with roots 4 feet deep when the ones in my field had just rotted off and were about 2 inches deep. So this has to do with the health of the soil. So by adding yellow mustard to the rotation, and we looked for a place where, how can we add this to the rotation without losing a crop? So we discovered it'll grow at low temperature. We threw it in our corn where we'd grown corn the year before and let it grow until early June and then turned it under ahead of the dry beans. It worked, and it actually worked sufficiently to make quite a difference. But George also said, now don't do all of it. He said, leave a few spots in the field and mark them where you didn't have mustard. He came back that summer and evaluated roots, and he could tell me with a shovel where I'd had mustard and where I hadn't, just by how the roots looked on the dry beans. There was that dramatic difference. So by adding one new species, the right one, we had eliminated this whole problem. It actually, our whole system had no brassicas in it. Go ahead.
How did your weed profile change once you incorporated brassicas into your cover crop rotation?
Okay, so I was just getting to that. We had been seeing an increase in mustard growing in our fields. I'd never had mustard problems. And at the same time that these dry beans were failing on me, we were having mustard pop up in the corn. And mustard's relatively easy to kill with a weeder, and it's relatively easy to cultivate out, except that you've got to be on the ball. If you miss it, it's very hard to get rid of if you're not there in the right window. So I should have noticed that. This all goes back to seeing what I'm looking at. I was seeing this problem in the dry beans, and I was seeing this annoying increase in mustard. If I had been paying attention to my soil, I would have said that, hey, that soil is trying to tell me something. It's trying to bring forth mustard. It's actually looking back, it was created so that the soil was trying to heal itself from the sickness that I was putting on it with an unbalanced rotation by bringing up this weed. In fact, I had another story to that. I told this story some years ago in South Dakota, and one of the farmers popped up and said, you just explained one of my biggest mysteries. He said, I had this field that was coming up in mustard, and it kept getting worse. And the last time I planted oats there, it was such bad mustard, I just let it go to bloom and plowed it under and got done with it because the mustard there wasn't going to be an oats crop anyway. He said, I haven't seen mustard in that field since.
It corrected the problem that it was designed to correct.
That's right. So
do you still have mustard in your field since you've incorporated it into your rotation?
No, and I've been just throwing the mustard on, and it doesn't even grow real well, but it's there. But I haven't seen it come as a weed since.
Fascinating.
So that's another we can learn from the soil.
Klaus, on a couple of different occasions, you've mentioned that you have a very diverse crop rotation. What does your crop rotation look like today?
At this point, we have 20 to 30 different crops, and it's very flexible because, first of all, I can drive my son crazy and some other people I work with because of the changes that I make, but I like to be able to respond to what the soil is showing me. So at this point, there's a basic rotation that we had started with that was very profitable, but we kind of wore it out. And that was corn, followed by soybeans, followed by winter spelt, underseeded to clover, and then the clover turned under the next year for corn. And that rotation was used by the university here and used by most of our neighbors. The problem is after about 10 years of this rotation, everyone started having the same problems. There was an increase in the Canada thistle on some farms that were doing this. There was this increase in disease. Now, the soybeans are much more resistant to the root rot and the nematodes than dry beans. But if somebody were to substitute, and that's what we were doing, we were substituting dry beans for some of the soybeans in that cycle, they would have had problems. So the first thing we added to this was put in a second cover crop, the yellow mustard, in the corn. But then we were starting to have more trouble. And the other thing is the clover wasn't growing as good. And we started seeing Canada thistle here and there. So we actually added, in the worst fields, we went from the winter grain spelt to a second winter grain, winter barley. And then we double cropped that winter barley with buckwheat the first couple of years. And by double cropping, we were breaking the ground up in midsummer, right in July, when you can hurt the Canada thistle and the other perennials. We weren't doing a lot of tillage. We were doing a deep tillage, a deep ripping, trying to leave the mulch on top. But then we discovered, well, buckwheat's not the most profitable crop in the world, and changing this rotation helped our soil quite a lot. So we discovered we could plant dry beans, pinto beans actually, after the barley, and then go back to a winter grain and then start over. So that stretched it out to a 5-year, 6-crop rotate, or 5 years. And I'm not even counting there. There must be 8 different species grown in that rotation. And then from there, we've diversified further. We've brought in vegetables after the clover so that we're not growing corn quite as often. We plant cabbage. We've thrown in squash after the small grains or even after the corn sometimes. And then from that, we've gone and added flax. We've added oats. We've added barley. Instead of just spelt, we've got rye, winter barley, spring barley, oats, wheat, triticale. And it seems like the fine tuning of this basic rotation makes it kind of. I feel more comfortable if I don't put it in stone and if I just kind of let the weeds and the soil tell me which one it wants to go to. But it's in this old basic framework that can branch out in 100 different directions. And I'm letting the weeds and the soil direct me as to what I do with it. So, sorry, it's not a very satisfying answer for people who want a set program or a formula. But I think the bigger answer is we need to be open to what the soil is showing us and just be more flexible in our rotations and think first of what will make the soil healthy and second of what's bringing the highest price.
Yeah, in a prior conversation with Don Hubert, he described that 85% of the benefit from crop rotation or from cover crops occurs from the immediately prior crop, so the crop that is planted just before the crop that you're growing. And I think the follow-up question to your long explanation of what your current rotation is, Don, is your answer was essentially, well, it depends based on what the soil and the weeds are telling me. And so this might be a topic for another conversation, but I would like to ask the question, okay, what are the variables that you're monitoring and how do you choose and select which crop you're planting based on what you're observing in the field?
Okay, I might be able to go at this from the other side, where what is it the soil is telling me based on some things that I look at. I don't know if that's useful or might be useful to you, but
Sure.
if I see a field that is dominated by a certain color, this is something that biodynamic farmers brought us years ago. Yellow blossoms point to sulfur. And of course, the yellow mustard, the compounds in the yellow mustard that have the big activity are sulfur compounds. And also, when we looked at our soil test where we had mustard growing, we had our sulfur was tied up. We were deficient in sulfur. And even though we thought we were putting plenty of sulfur on, those weeds were telling us, no, you're not putting enough on. We're still short. So that's, there are a lot of side stories to all these things. The blue flowers are quite often a phosphorus indicator. White flowers are potassium, but can be calcium depending on situation. So that's just one of those general hints that we get looking at the field. If I see corn chamomile overrunning a field, I can be quite sure that there's a calcium issue. And if I see milkweed, I'm 90% sure we're short of zinc. At least there might be zinc on the soil test, but the crops aren't getting it. It could be complex. And hemp dogbane is the same. And these are all I don't want people to take this instead of soil testing. These are little data points and observations that I've made that are parts of the conversation when the soil is showing me things. And Dave Maddox, I have to credit Dave Maddox on the zinc. First time I saw him, this is way back, I was still trying to figure out if he was someone I wanted to deal with. He was trying to figure out where I was coming from, and we were discovering that we were, at least in theology, very, very much in alignment with each other. And then he drove by a couple of fields and he said, "I see you got a zinc deficiency." And I said, "What are you talking about, Dave? You haven't seen a soil test here yet." And he said, "I don't need a soil test. I see your milkweed." So I thought that was an interesting little anecdote. But those are things, if I see foxtail, I can guarantee you that soil is suffocating, that it's not getting enough oxygen, and then it's not able to get rid of the carbon dioxide and the ethylene and some of the products of respirations that build up. So I used to tell people it's tight soil, but it's actually more than tight. It's not just, if you could have pure sand be loaded with foxtail if you have enough rain that the soil's not breathing. So that, I don't know, I could go on and on with examples, but that's kind of where I'm coming from when I figure these things out. And if I see foxtail growing, for instance, and I've got an opportunity in the rotation, I would love to grow millet, because millet will do the same. Millet loves the same conditions that foxtail does, because it's genetically very similar to foxtail, and it'll repair the same maladies in the soil. So if I see the soil trying to grow foxtail, I'm going to have some millet there the first chance I get, or the next chance I get, because I know the millet will love that soil condition, and the soil will be corrected by the millet. And that's another thing we're doing is if we see certain weeds that either have a given function or that are closely related to a crop, that's the soil telling me, well, this crop is going to do great here, but don't be trying to plant what you were planning on, because I'm showing you with my weeds that it's not going to be happy here. Does that help any? Or?
Yeah, that's a great answer, Klaus. Thank you, and I'd love to unravel that more, but perhaps in a future conversation. I'd like to shift gears for just a moment. When essentially what we're talking about, what we're describing, is managing an ecosystem, looking at the entire soil plant system, and managing how that is developing and evolving, both with crop rotations and with tillage and the various tools that we have. How have you seen the ecosystem evolve in regards to disease and insect resistance as you looked at managing the entire ecosystem? I know that in earlier discussions, you've referenced a couple of examples of managing aphids on lettuce by managing the ecosystem, and I wondered what thoughts you would have to share on that.
Yeah, the aphid one on lettuce is one of those just absolutely amazing ones. This was research, university research done in California, where there was an aphid that was getting into the heart of the romaine lettuce and making it totally unmarketable. And one of my friends there was doing research on how do we control this in an organic system, because on the conventional lettuce farms, there's I'm sure anyone that's been in Salinas Valley, that some of those parts of California are just this vast wasteland of only one species, only lettuce. And what they did was they found out that sweet alyssum, the flower, promotes an insect that controls the aphid, that actually eats the aphid. They found out that if they had one sweet alyssum plant planted on every 1,000 square feet through the lettuce field, it did not reduce the yield of lettuce at all. It was identical, same yield of lettuce, but that one plant every 1,000 square feet completely eliminated the aphid from the field. That's just an example of how introducing the right plant in the right place at the right time can completely remove one group of insects.
That's almost nothing. I mean, that's 44 plants per acre.
That's right. Yeah. And to have that dramatic an impact, I bet the cost of the spray that they would be putting on every week or 10 days at that point has got to far exceed the cost of those flowers that they're planting out there.
Yeah, exactly. What have you observed on your own farm in regards to disease and insect resistance over the years?
Well, we're seeing, I think we're seeing some of what's behind people paying attention to bricks. When we have healthy plants, the bugs just don't seem to hit them. Although I have seen in cabbage, this is with a cabbage aphid, and to me the aphids must be a special case. They drove me crazy at first. Then I noticed that where I had corn planted next to cabbage, as long as the strips were not more than 150 feet wide, I had no problems with I had no problems with cabbage aphid. And what we learned afterwards was that the lady beetles were feeding on insects in the corn, and about the time the corn matured to the point where there was no food for the lady beetles, they just hopped down into the cabbage and started cleaning up the aphids in the cabbage field. That was very similar to the mechanism mode of action that we saw in the lettuce. Even with that tiny amount, I'm wondering now after the lettuce experiment, if somebody could just drop some sweet corn plants out in their cabbage field, that might be insurance against aphid. But having the narrow strips certainly works good too, and that saves you having to cut roadways open. You've got a different crop right next to it. But another thing we've seen in our fields is if we start seeing leaf hoppers, for instance, moving into either dry beans or alfalfa or potatoes, any of these crops that have leaf hopper problems, I'm almost assured that these plants are low in magnesium. And I found that I can spray Epsom salts on the field instead of an insecticide, and you'll see the crop greening up and perking up and looking better. And in some cases, the insects just totally disappear. They just avoid those plants.
Yeah, I have a thought for you on both aphids and the leafhoppers. We have, and it's been our experience working with a number of different crops. We've observed that there's this triode, if you will, these three different nutrients: magnesium, sulfur, and molybdenum.
Mm-hmm.
Each one of those three needs to be an adequate supply. And if you have adequate levels of two, but the third one is low, you have challenges with aphids, for example, and leafhoppers. But if all three are adequate, those insect pests just disappear. And it's pretty profound, actually. I would say we have a 90+% success rate. Actually, I'm saying that just to be conservative. In reality, it's probably close to 100% success rate dealing with aphids on a broad range of different crops.
In this case, your Epsom salts are covering two of those bases.
Yeah, exactly.
So we may or may not know what we're doing, but we get the right result. At least on our farm. And that's really an interesting point for you to bring up, because magnesium and sulfur are quite often linked when we over-fertilize or when we don't have the right fertilizer program. We're being too high in magnesium will tie up magnesium. You can be either too high or too low in magnesium in the soil and end up with a deficiency in the plant. Or if you're short of sulfur in the soil, you could also end up being deficient in magnesium and calcium, because they would become insoluble in those situations.
Exactly.
Yes. So then the big question is, we need to get the missing element out there, but we also need to figure out why was it missing. And in that case, we're doing two things. We're having to kill the bugs so that we actually have a harvestable crop, but we really should be addressing the reason that we had to go in and do something.
Well, the reality is, and I'm sure you've experienced this as you expressed as well, but in many cases, we find that these foliar nutrient applications can be incredibly effective as in pest removal. I don't want to say as a pesticide, but we have a number of experiences where we put on a nutritional application, 100% nutrition, doesn't contain any toxins at all of any kind, and spider mites are dead in 48 hours. Aphids, leafhoppers disappear in 24 hours. It's pretty profound. It happens really fast.
And it's the plant's able to launch a defense that was just crippled by the shortage of that nutrient.
Exactly.
These plants they were created to be able to handle the pest. The pest and the plant were both created by the same. And if one can't live with the other one, it's usually an imbalance. So you're dealing with it right there. But I would also say that we really need to pay attention to why was this deficiency there. And we tended to see the soybean aphid in spots that were very high in potassium. High potassium tends to lock out magnesium. We can have we have deficiencies that are induced by excesses sometimes. And one of my favorite quips is that I've seen more farmers buy themselves expensive problems than expensive solutions. When somebody comes to sell you a huge amount of something, especially if it's out of the ordinary, that be careful. You may be buying yourself a different problem.
Klaus, you just mentioned a very key phrase, is that you may actually have excesses being more of a problem. We first began experimenting with the use of sap analysis in 2011, and we started using it on a very intense, broad scale in 2013. And now, after having several years of experience with sap analysis, I can say that most of the nutritional imbalances that crops experience are not a result of deficiencies. They are a result of the excesses of products that growers apply, creating deficiencies of something else. 90% of nutrient imbalances are created by the grower.
That's right.
It's incredible. It's absolutely incredible. Many of the recommendations that we make consist of discontinuing product applications or positioning them at a different time. It's really profound.
Yes. So, you put your finger on, I think, the biggest and most common problem that I've run into. And that's over-application of something that creates an imbalance. Yep. Because if it's good, a whole lot might not be better. And if you take this in history. Von Liebig wrote The Law of the Minimum. There's this illustration of the barrel with which stave is lowest. But just shortly after that, Andre Voisin wrote a pamphlet called The Law of the Maximum, which said that when any one mineral is in excess, it can cause a shortage of one or more others.
Yeah, exactly. Klaus, you think a lot about what is happening in agriculture ecosystems from a macro perspective. What is something that you believe to be true about modern agriculture that many other people do not believe to be true?
Well, to me, modern agriculture, and I'm going to include genetic engineering, is a series of enabling tools that allow the farmers to continue bad management. That in a natural system or a balanced system where farmers are in harmony with the creation, with the soil, with their farm, when they're doing something that they shouldn't be, the soil is basically screaming. If we persist in doing it, the soil starts screaming very loudly, and we'll see these problems pop up. Be it a weed, be it an insect, be it a disease, whatever, but these are symptoms. And modern agriculture has gone to being a series of treatments, materials, things that we can buy that make us able to continue the bad behavior, the offending behavior, but never deal with the actual underlying problem, which is why it damages the long-term productivity of the soil. And the analogy I like to use, it's a little bit like if the idiot light comes on your car telling you there's low oil pressure, putting tape over the light or clipping the wire takes care of the immediate symptom. The light goes back out, but it does nothing to deal with the reason that light was on. Or if we take it on a spiritual level, let's say somebody is in error or in sin, and the minister or the bishop are pointing out that you really need to stop doing that. Well, we can ignore them. We can not listen. We could go find another bishop who will say something different. And it doesn't take away the problem, and it really won't take away the long-term results of the problem. So I don't know if that analogy makes sense to you, but to me, that's what it feels like.
Yeah. No, I think one of the pieces that we discuss often is that we've become addicted to point-and-shoot solutions rather than identifying the underlying causes and really thinking about the underlying causes of various challenges.
Right. And those challenges then are seen as our enemy instead of as nature essentially pointing out error to us.
Yeah, exactly.
They actually become used for improvement.
Klaus, you do a lot of reading and a lot of thinking about what is happening on your operation, things that you see happening around the country. What are some books or resources that you would recommend to growers?
Well, I love the Albrecht papers, but they can be dense. They can take a lot of discipline to learn from them. There was an old, not well known anymore book. It was a Cornell text on weeds that was used for 40 years. And it was Conrad Minchner was the author. I know Acres reprinted it. It was simply titled Weeds. And what I loved about that, it had the line drawings of all the weeds, but it gave control methods. And on each one, it gave them in a community where if it was a family of plants, it would give all the members of the family, it would describe the differences between them and the descriptions to help you identify them. But it would also say where it grows and when it grows and what conditions favor it. And then it gave us a list of cultural practices in the back that could be used to eliminate it or reduce it. And I found that to be, especially in my early years, really helpful, because instead of just identifying the weed and finding a chemical to kill it or a tool to kill it, this was identifying the weed and learning about it and trying to, getting some information that helps us understand what it's telling us. There's a book that will be coming out.
Klaus, just to finish on that, I know that Acres has a book titled "Weeds Control Without Poisons" that was either authored or by Charles Walters. Is that the one you're referring to?
Well, this is not the same one. This was an old Cornell text that I'm referring to by Conrad Minchner. I did have also Charles Walters' book, "Control Without Poisons," and another one, "Weeds and What They Tell." I guess one of them is "Weeds and What They Tell." And the other one was "Weeds and Control Without Poisons."
Right. "Weeds and What They Tell" is authored by Jay McCammon, and "Weeds Without Poisons" is by Charles Walters.
But I would caution. I really like the Cornell text because it was more basic background information without talking about more detail. It's kind of the 101 level. What I found as a caution with the two Acres books is we shouldn't get too hung up on that this is the story this weed is telling me. They're more complex. So I use those as aids, but I don't want to get so narrow that what it said in the book is the only thing this tells me in the field. I don't know if that helps. So it all each one becomes a piece of what could be a much bigger story.
I apologize for interrupting. You were mentioning something else as well.
Yeah. The weeds. It's now I lost it. There was another. I was just thinking of another book that has been influential to me. But I would recommend people buying the Albrecht papers. Yes, another one that I would highly recommend everybody should have is Andre Voisin, Soil, Grass, and Cancer. And to me, that's a really brilliant early piece of observation that was connecting the minerals in the soil and to some really bad diseases, both shortages and surpluses. This is looking at diseases that modern medicine still can't get their finger around. And yet, way back in the 1800s, this French veterinarian was making connections between soil fertility and these and health. And again, I caution against looking at this as written in stone. If I see this is happening, but more as a general framework for us. I think we all know a lot more than we give ourselves credit for. I'm hoping that the big thing I can teach people is to use what they already know, to use what they've already seen, and then to look forward and train ourselves to see more, to see the right things, so that we can learn, so that we can draw our own conclusions about our own farm, because nobody knows more about your farm than you do. That's the one that you live on. That's the one that you see every day. And you don't need an intercessor to talk to your soil. You can talk to your soil yourself and learn from it and pray for the Spirit to guide you to see the right things, and also pray for the discernment to figure out the right lessons from what we're seeing.
I love that thought, Klaus, that we don't need an intercessor. And I think that is, we are the experts on our own operation. Nobody knows them as well as we do. I think that's a very, very key thought that is often lost.
I think it's very important for us as advisors, because I need to remind myself that I am only a tool, and that if I've been given gifts of observation and gifts of knowledge, but I'm not the source of that knowledge. I have to give credit to the source of the knowledge, and just give thanks that I can be the conductor of it, to share some of it with other people.
What is the question you wish I would have asked?
Well, that's a good one. I think maybe where do we find, the question would be, where do we find help and guidance and discernment in managing our farms? I think that's really the most important question. I really don't want anyone to come away thinking that any one person is the source of this, of what's good.
Let's unwrap that a little bit, Klaus. What are the sources that you have found useful and helpful for guidance and input, and most important to you? And also, what do you believe are important for the growers that you are working with?
Okay, the most important source I've found has actually been having quiet time and prayer time in the field. Just asking for discernment and asking for that help. And to me, that's been strong. But along with that, what was really important, and I'm sure you play this role often in your work with farmers, is to have farmers or people that can give guidance to help me with the discernment and to help me get started in that. And for that, I find groups of farmers. We have our group that meets every winter here in Geneva, NYCO, where, because we're working together, we can all share things. We can share observations, ideas, what worked, what didn't work, but we kind of need to keep each other grounded in doing this. So that, this becomes a community thing, but we always have to include in that community the source of all that knowledge and all that wisdom, which is not from any one of us. And to me, it's that I'm reminding myself more than anyone on this talk that I've been entrusted with a lot of insight and some really great gifts, but none of them came from me. And all I can do is hope that I can steward them correctly.
Absolutely. Very powerful thoughts. And I completely agree with you. Klaus, thank you so much for joining us and for sharing the wisdom that you've been given to steward. Very much appreciate you being on here. And we look forward to speaking with you again at some point in the future. Thank you very much.
Thank you for doing this work. I'm sure this extends help to a lot of farmers.
This podcast was brought to you by a great company that I happen to work for, AEA, Advancing Eco Agriculture, the leader in regenerative agriculture since 2006. At AEA, we believe in challenging the status quo to find more profitable and regenerative ways to grow crops. We also believe that healthy plants are resistant to pest and disease, that to grow healthy plants, we must first think different about agriculture. about empowering life instead of suppressing life, about regeneration versus degeneration. To achieve this, we formulate and sell products that help growers produce higher quality yield with less risk of crop failure. In short, we help growers make more money with less risk. If you'd like to learn more about our programs and systems, call Jason Stoll, a highly regarded AEA consultant and my teammate, at 800-495-6603, extension 344. Again, that number is 800-495-6603, extension 344. And mention the code podcast10 to get a special incentive with your first order. Thanks for listening.